Alright, welcome to this lesson, and in this video we have been asked to find the dy dx of these two functions. And the first one is y equals ln x over x squared, as you can see, and the second is y equals sin x over cos x, and we have to use the quotient rule for this problem. You already know what the quotient rule says. It says that if you have two functions that are rational, if you have rational function in the form of f of x, or let's equal it to y equals, let's say, g of x all over h of x, but I would say u of x all over g of x, because I would love to use this in the formula, and that will be v of x, where this v of x is not equal to 0, and the quotient rule says that the dy dx of this function is equal to, you say you should keep the second function, and differentiate the first function, that is u prime of x, minus, you should keep the first function and differentiate the second function all over the square of the second function. If you are able to do this, then you have just differentiated using the quotient rule representation. So let us apply that rule on the function, on the first one, and see what we get. Let's quickly do so and see what we get. Now, obviously we can see that u of x here corresponds to this ln x, and v of x corresponds to this, and x squared is not equal to 0. So now we can say u of x is equal to ln x, and v of x is equal to x squared, where this is u of x and here is v of x for the first question. Now u prime of x, we already know this from previous examples, will be equal to 1 over x by the ln x rule, and that this will be v prime of x will be 2x by the power rule. So let us apply this here and see what we get. So the y all over the x will be equal to, the rule says that we should keep the second function, one, which is the x squared, and into the first function derivative, that is 1 all over x, minus, keep the first one now, which is ln x, into the second function derivative, which is 2x, all over the squared of the second function, x squared to the second power. And what would this give us? This, let me take this ruler. Now x, we cancel x, we have 1x left here, so we have the y all over the x, lastly, will be equal to x minus 2x ln x over x to the power 4. That is the answer to the first problem. Now the second problem, this is the answer to the first problem, this one. Now to the second problem, we have y equals sine of x all over cosine of x. Now we can pick u to be sine of x and v to be cosine of x, and this will mean that u prime of x will be cosine of x, and the v prime of x will be negative sine of x. So let us compute our quotient rule finally and see what we get. So the y dx will be equal to, keep the second function, which is cosine x, and define the first function, which will give us cosine of x again, minus, now keep the first function now, which is sine of x, and define the second function, which is negative sine of x, all over the squared of the second function, which is cos x all squared. Now all squared, so this will be, cos x times cos x will be cos squared x, minus sine x times this will be negative sine squared x, times this positive sine squared x. So cos squared x plus sine squared x by the ideal rule is always equal to 1, and that is 1 all over cos squared x. So at the end of the day, the y all over the x for this function will be 1 dividing cos squared x. That is the answer to the second problem. Thank you, and see you in the next lesson.